Hello friends, in today's session we are going to cover some more interested topics regarding our chapter. Okay, so we will start now. Now we will see requires transitive. What is requires plus transitive in modules? Consider a situation like there are three modules A, B, C, and A is requiring B, B is requiring C. It is clear that since A is dependent upon B and B is dependent upon C, A has indirect dependence on C, like we have already introduced in mathematics. Okay, so A depends on B, B depends on C, so A indirectly, A has an indirect dependence on C. So C is dependent on A, like this. Okay, as long as A does not directly use any of the contents of C, then you can simply have A require B in module info.file and B export the packages required by A in its module info.file, like this. Okay, module A requires B and module B exports some packet or any package name that you will provide and requires C. Some package is a placeholder for the package exported by B and used by A, because A is requiring B and whatever package is required by A, that will be exported by module B, and B is requiring C. Okay, and this is in the situation where A does not directly use any of the contents of C, like A has when there is no indirect dependence from A to C. So in this situation, we can create these modules like this. Although this works as long as A does not need to use anything defined in C. Okay, so these two modules are sufficient because only B is requiring C. A does not require C. Only A requires B and B is requiring C, but A does not require anything regarding C. Okay, a problem occurs if A wants to access anything inside the module C. So there are two answers to this question. First is simply add require C statement to A's file, like A is also requiring B and B and also requiring C. Okay, this solution now works, but if B will be used by many modules. B modules will be used by many modules. You must add require C to all module definitions that require B. Okay, so each and every module that requires B, you will have to add the line like module B requires B. But if B will be used by many modules, means if every module, if B requires C to all module definitions, like E requires C, F requires C, T requires C, and so on. This is not only tedious but also error prone. It can create errors. There is a better solution to this. You can create an implied dependence on C. This dependence is also referred to as implied readability. Okay, A is dependent on B and B is dependent on C. So A is indirectly dependent on C. In that situation, implied readability takes place. To create an implied dependence, add the transitive keyword after the requires in the clause that requires the module upon which an implied readability is needed. Okay. In this example, you would change B's module info.file like this. B exports some package that is required by module A and requires transitive C. So, in the previous example, we added require C, and in this example, we are adding requires transitive C. Okay, so why we are adding this transitive keyword over here? We are adding the transitive keyword because after requires in the clause, because it requires the module upon which an implied readability is needed. Okay, C is now required as transitive. A requires B requires C, and A also requires C. Any module that depends upon B also automatically depend upon C. Okay. A would automatically have access to C if you are using this transitive keyword. Okay, when you will add this transitive keyword, any module that depends upon B will also automatically depend upon C. So it will access, in this case, here A is dependent upon B and also dependent upon C. So like A, if there is any other module that requires B and C, in this case, A would automatically have access to C because of this transitive keyword. Requires transitive by reworking the preceding modular application so that each factor method is removed from the simple mathematical function class in the app functions dot simple function package and put into a new class module and package. Okay, so if you want to implement it as an example, how you can experiment it with requires transitive by reworking the preceding modular application example that we have seen in the previous session. Each factor method is removed from the simple mathematical function class. Okay, in which package app functions dot simple function and put into a new class module and package. New class will be called as support function. The module will be called app support, and the package will be called app support dot support functions. In that you will have the class support functions dot java. So what will be the hierarchy? App support module dot support functions package. Okay, package will be called as module name dot package name like app support dot support functions, and in that class we will have a class. In that we will have a class java file like this, support functions dot java. App functions module will then add a dependence on the app support module by use of requires transitive. Okay, so app functions module will add requires transitive keyword as a combination, and it will add a dependence upon app support module. This will enable both the app functions and abstract modules to access it without abstract having to provide its own required statement. Okay, in this case, app functions and abstract both will have access to that app support new module created without abstract having to provide own request statement like we have seen in this video first example. Okay, like A is requiring B and also requiring C, that second request will be removed. This works because abstract receives access to it through an app functions requires transitive statement. Okay, so to explain in detail we have to use the example. Create a source directory that supports the new app support module. Create the app support under the app source directory. This is the module directory for the support functions. Okay, this is the module directory app support. Under app support, create a package directory support functions. It will be read as app support dot support functions. So the directory is tree for the app support. Now we will look it. Now it will look like this: app source, then app support, and then support function as a package name. And inside that we will have the support functions dot java. Okay, so we will create the class support functions class. Support functions is a part of app support dot support function package. Okay, so you will put it in that hierarchy we have already created right now. Now support functions package app support dot support functions. Okay, so find out if A is a factor of B. Okay, if B module A, like B is completely divisible by A, then it is true, that is A is a factor of B, otherwise A is not factor of B. Now each factor is now part of support functions rather than simple mathematical functions. Then next we will create module info.java file for the app support module we have created right now and put it in app source app support directory. Okay. Module definition for app support. Here we will create it. It is an app support module. Exports app support.support functions. Okay. It exports the app support.support functions package completely. And each factor is now part of support functions.java file that we have created here. It's the support functions.java. Okay. Remove it from simple mathematical functions because our class will have transitive dependency on this class support functions.java. Now simple mathematical function.java will be like this, where each factor method is removed from this app functions.simple functions and import app support.support functions.support function. This support function is having its factor method. In the simple mathematical function, we will have only two methods, least common factor and greatest common factor. Okay. Return the smallest positive factor common in A and B. Okay. Then public static integer least common factor AB, factor using positive values. A is equal to mat.absolute A, B is equal to mat.absolute B. Then minimum is equal to A less than B. Okay, so minimum will be found as A here, and from 2 to minimum divided by 2 because each and every digit is divisible by 1 itself. So from 1 to minimum divided by 2, that is half of minimum. We will find out support functions dot each factor because we are using each factor now from support functions dot java file I comma A and support functions dot each factor I comma B, that gives the least common factor, and otherwise return 1. Then return the largest positive factor. So it will be like factor using positive values. A is equal to mat.absolute A, B is equal to mat.absolute B. From minimum divided by 2 and I greater than equal to 2, we will go in the reverse direction. If both are factor, I is the factor of A, then I is the factor of B, then it will be common factor of A and B. Otherwise, 1 will be the factor. Okay. Notice that now support functions class is imported and calls to each factor are referred to through the class name support functions. Okay. Now we are importing the class support functions and calls to each factor are referred to through the class name support functions dot each factor. Okay, we are not using it from simple mathematical functions. Next, change the module info.java for the app function so that in its required statement app support is provided as transitive like this. So we will change now app functions. Export the package app functions dot simple functions, exports app functions dot simple functions. Okay, so app support is transitive now, requires transitive app support. In which module? App functions. So its before module which is dependent upon this module. This will also have access to app support package or sorry app support module. Because app functions requires app support as transitive, there is no need for the module info.java file. For abstract to also require it. Okay, so abstract will also have the access to app support. Its dependence upon app support is implied over here. And no changes to the module info.java for the abstract are needed. Like we are not requiring one more require statement adding to the our abstract module. Okay, so we will only have require statement for app functions. So abstract requires app functions export app functions dot simple functions to our abstract, and then it requires transitive app support, so that these app functions will also have access to app support, and its before module app start will also have access to app support. So both will have access to app support at the same time. Update my mod app demo like this to reflect this particular changes. Now it must import the support function class and specify when invoking each factor like this. Import app functions dot simple functions dot simple mathematical functions and app support functions and support function which is having each factor method. So in a public static void main, now we will access each factor via app support functions like this. In the previous example, support functions dot each factor. So if 10 is divisible by 2, completely divisible, then 2 is a factor of 10. Least common factor between 35 and 105, largest common factor between 35 and 105. Once you have completed all of the preceding steps, you can recompile the same program and you will have the output. Okay, using this multi-module compilation command, which is the command like this: java c -d app modules -- module source path app source app source start app start my mod app demo dot java. The multi-module compilation will automatically create parallel module subdirectories under the app module directory. Okay. Then you will run this program java -- module path app modules -m app start dot my mod app demo dot my mod app demo. So it will have the same output as the previous example. This time 3 different modules are required. To prove that transitive modifier is actually required by the application, remove it from module info for app functions. Okay. Then try to recompile the program and try to access the support functions.java without adding the require statement in our first module, that is app start module. It will give you compile time error. Okay, because app support is not accessible by app start. If you will remove the transitive keyword from that app functions module, you will your app start will not have access to app support module. Okay, now we will see one more example. In the module info file of app support, try exporting the app support dot support function to only app functions, so it will not be accessible to app start by using the qualified export. Export app support functions to only app functions, so that your program will not run. You will have the compile time error. Okay, program will not compile because now the support function each factor is not available to app start module. Qualified export restrict access to package to only those modules specified by the true clause. Okay, because of the special exception in the Java language syntax, in the request statement, if transitive is immediately followed by a separator such as semicolon, it is interpreted as an identifier, not an keyword. Okay. So one more exception you have to remember: if you are writing like this, requires, then transitive, then any other separator. For example, separator can be anything, like it can be colon, it can be comma, it can be semicolon. So here is we have given example as a semicolon. If it is a semicolon, transitive will be treated as a identifier or name of the variable, such as module name, or it will not operate as a keyword. So this time this transitive will not work to have the dependency from module A to module C. Okay. Next, use services. In programming, it is often useful to separate what must be done from how it is done. Okay. So we have to separate what is to be done from how is to be done. One way is this is accomplished in the use of interfaces. So interfaces will have only the definition, only the declaration, what is to be done, and not the definition, not known how is to be done. The interface specifies the what, implementing class specifies the how. This can be expanded to that so that implementing class is provided by code that is outside of your program through the use of plugin. Okay, so you are only providing what is to be done, and how is to be done is provided from outside, okay, through the use of plugin. The capabilities of application in this way are enhanced, upgraded, or altered by simply changing the plugin. Okay, so you will provide the plugin from outside, and when you will change the plugin, every time you are upgrading the plugin, every time your application will be upgraded to next level. It can be enhanced to next level or simply altered by alter to next level. Okay, so what you have to change, only you have to change plugin if you want to modify or enhance your project. The core of the application itself remains unchanged. Okay, so interface declaration is done by you, interface definition is given by outside, that is from plugin. One way that Java support a pluggable application is through the use of services and service providers. Okay, this is the very good example. Because of their importance of services and service providers, especially in large commercial applications, Java's module system provides support for them. Java's module system provides support for whom? Services and service providers. It is necessary to state that applications that use services and service providers are typically fairly sophisticated. Okay, applications that are using services and service providers, those are fairly sophisticated. You may find that you do not often need the service-based module feature most of the time, because support for services constitutes a rather significant part of the module system. It is important that you have a general understanding of how this feature work. Okay, also a simple example is presented. So what you have to remember, support for services, like your modules is supporting services and service provider. It constitutes a rather significant part of the module system. Okay, rather significant part of the already existing module system. You have general understanding. You should have general understanding how services and service provider work. Also, a simple example we are going to see now that illustrates the core techniques needed to use it. So we will see the service and service provider basic. Service is a program unit whose functionality is defined by interface or abstract class. Okay, what is to be done? That is only declaration, not definition. Service is a program whose functionality is defined by interface or abstract class. Service specifies in general way some form of program activity. Concrete implementation of service is supplied by service provider. Service defines a form of some action and service provider supplies or provides that action. Services are often used to support pluggable architecture. Okay, a service might be used to support translation of one language to another language, like a pluggable architecture. Service support translation in general, and service support actually translate. Okay, so service only tells that it is supporting the translation, and service provider actually translates the languages. The service provider supplies specific translation such as German to English, French to Chinese. The service is a generalized syntax of translation in this case, and specific translation implemented actually will be like German to English or French to Chinese will be given by service provider. All service providers implement the same interface, like one method only declaration. Different translators can be used to translate different languages without having to change the core of the application. Okay, so only one method declaration will be given, and all service provider will implement the same interface to actually translate the language from any language to any language. You can simply change the service provider. Okay, service will be same. Service providers are supported by service loader class. And service loader class is a generalized class, generic class provided in java.util package. Okay, so what is the core of this? Service is the thing which is only having the abstract classes or interfaces. Those will be common, those will be generalized. You can change the service provider. Okay, in this particular example, we have seen that service provider will actually translate the language. It can use the same syntax, same method declaration to translate from any language to any language. You can change the service provider, but service will be same. Service providers are provided in the service loader class, and this class is included in java.util package. So class service loader is declared like this. Class service loader S. S specifies the service type. Okay. And actually service providers are loaded by load method. Load method has several different formats. The one will be used like this. Public static S. S is a service type. Service loader S, load, class S, service type. Service type specifies the class object for the desired service type. Okay. So class service loader is declared like class service loader, and load method is public static service loader. It is returning the service loader object, load, class service type, and service type is the class object for the desired service type. Class is a class that encapsulates information about a class. Complete information of a class is given by class. There are varieties of ways to obtain a class object. The way we will be used, that involves the class constant, class name dot class. In this way, we will obtain the class literal or class constant. Okay, or a class instance can be accessed. The way will be used is involves the class literal, and class literal format is class name dot class. Class name specifies the name of the class. When load is called, it returns a service loader instance for the particular application. It returns a service loader object. When load will be called, it will return the service loader object. This object supports iteration and can be cycled to the use of for each type for loop. Okay. To find a specific provider, simply search it using a loop. You can use any loop to search for particular service provider, like for each type for loop. Okay. In this way, we have completed some interested topics regarding our modules. Okay. So in the next session, we will see more interesting topics. The topics we have covered, you can practice them at home. You can try different techniques on it, and you should enjoy this programming process. Okay. If you are not understanding anything, you can go back and revise. If you are understanding theory part perfectly, then we will be having practical very much clear. Okay. So enjoy the process, enjoy the module session. Meet you in the next session with the new theory topics. Meet you in the next session. Thank you so much.